Wait, Stella, how do you do that?
Okay, so did everybody get the first 3 graphs in?
Yes.
Okay, so tell me, what do you notice on the, when you have x plus 2 with the plus 2 on the inside? Viviana, what do you see?
It changes the vertices of the graph, and instead of being 0, it's -2.
Okay, just the vertex? Or?
No, yeah, just the vertex.
Well, it's just the vertex moving.
No,
The whole graph, yes. Everything shifted over
the middle
2.
of it shifts,
To the left
and
2.
then the rest of it shifts.
Okay, what happened when you did the minus 3?
Right. Same thing, but
Goes right by 3. Thank you.
to the left.
Okay. All right. So I want you to go ahead and delete those bottom 2 graphs and now graph the absolute value of x plus 2 on the outside and also minus 3 with it on the outside. Okay. Stella was ready already. What happened with the plus 2 on the outside?
When you go outside, it goes up and down on the y-axis.
Okay. So this goes up by 2. And what happened with the minus 3?
It went down.
Down by 3. Okay, go ahead and delete those bottom 2 graphs. And now I want you to graph the absolute value of 2 times x and then also 2 times the absolute value of x. Okay, so what happened when we multiplied by the 2? What'd you see, Caraday?
Oh, this slope, it's like up 2 over 1. Like it shrinks.
Okay, so we'll just say that, okay, so, all right, we're going to talk more about that. But the graph narrowed for both of them. Did it end up graphing the exact same outcome?
Yes.
It did. Okay, so we're just going to say for now that the graph narrows. Did the vertex move?
No.
No.
Wait, was 2x and 2 like so those graphs were the same?
Well, there's a different effect, but it ends up doing the same thing. Okay, go ahead and delete those bottom 2 graphs and now graph the absolute value of negative x and then also the negative absolute value of x. Okay, what happened when you did the absolute value of negative x? What'd you see, Avani? It looked the same. Okay, so this one looks the same. Okay, what happened when we did the negative, Allison?
It's now negative because the negative was on the outside of the absolute value.
Okay, and what was the effect on the graph? What did it end up doing?
Oh, it was a reflection.
Reflection. Okay. And it reflected over the x-axis. Okay. So then, that one you can see, it flips down. Did the first one that we did, was that also a reflection?
No.
No?
Reflection of which one?
The first one, with the absolute value of negative x.
No, the absolute value of negative x just happens.
It's not. It makes no.
Because it's the distance or same distance.
Okay. So we just said with the negative on the outside, it reflected over the x-axis.
So there's a reflection.
There is a reflection, but what was it over? The y, but because of the symmetry of it, it ends up looking exactly the same. Okay, so let's go over. I've got a little table here, so we're just going to kind of fill in the things that we see. Okay, so when we have an addition or subtraction that happens to the x, okay, so as we see here, f of x plus or minus h. That plus or minus h is occurring to the x on the inside. All right, so we saw when we did plus h, what happened? What direction did we move?
To the right.
It shifts left.
Okay.
Shifts left. H. All And when we did minus h, what happened?
Shifts right.
Shifts right by h. Okay, so like we saw in this one, when we did f of x is equal to, we had x plus 2, and this one was f of x equals x minus 3. Okay, and then I'm just going to make a little note on here. Affects x, y stays the same. Okay. All right. Now we also had plus or minus on the outside of the parentheses. So we say f of x plus or minus k. And so when we did plus k, which direction did we go?
To the left.
Remember, it's on the outside.
Inside of the...
Oh,
It's on the outside,
Oh,
so
on the
it
outside.
shifts
It goes
up.
up.
Yes. So this one shifts up k. And when we did minus k, it shifts down k.
so does this one not affect the x?
Exactly. So this one was absolute value of x and then plus 2 on the outside. This one was the absolute value of x minus 3, and the minus was on the outside. And so yes, this affects y, and x stays the same. Okay. Alrighty. So, on the next one, I know that we graphed it with both 2 on the inside and 2 on the outside, and the graphs looked exactly the same. But the effect of how you get there is actually different. With the first one, with the A attached to the X on the inside, this is going to be relative to the X-axis. Or we'll say relative to the X values. And we get either a stretch or a shrink depending on the whether we are moving away from the x-axis or moving towards it. Yes.
For this one, are you talking about like when it was like 2x?
Mm-hmm.
I didn't get the same exact graph like that.
Yeah, so they should come out the same. Let me pull this up. So, okay. So I'm going to go ahead and graph the parent function in here.
Is this unit 2?
No. Yeah.
Yeah, we're in unit 2. Okay.
2.6, 2.1.
And so we have this one here, 2x. Right. And then we have this one here, 2 times the absolute value of x. Okay. So exactly the same. But again, the effect of what's happening is different. With this one, the blue one, I'll go ahead and delete this one. Let's just look at this blue one first. So what's happening is, again, we are affecting x values, and the x values get multiplied by the reciprocal of that constant that's attached to it, all right? So when we do 2x, what is the reciprocal of 2?
1/2.
Is 1/2. Okay, so it affects the x values by 1/2, not by 2. So if we look over here, our original point on the graph is x equals 2, y equals 2. Okay, so again, we're affecting the x values. So when we take x equals 2 and we multiply it by 1/2, x becomes 1. And that's what shifts it over here. Okay. Same thing on the other side. If we take x equals -2 and multiply it by 1/2, it takes us to -1. The y didn't change. Okay. Same thing over here. X equals 4 at this point, divided by 2 makes x equal 2. Y didn't change. Okay. So that's the effect when we are when we're multiplying on the inside. Okay, so what we want to keep in mind is we have a reciprocal relationship. All right, and then I'm going to make a note here. These multiply x values, bless you,
Thank you.
by the reciprocal of a. Okay. So when we have the absolute value of a greater than 1, let's talk about the effect here. Okay, so right now the absolute value of a is greater than 1. Did the graph stretch towards the x-axis or shrink away from the x-axis?
Away from the x-axis.
It is shrinking away. Okay, so shrinks away.
Wait, so the blue line would be a shrink of the parent function?
Yes, on a shrink from x.
Okay, because okay.
Yes. Okay, so this is a shrink, or let's say it's a horizontal shrink.
Also, what are you talking about when you say a?
The number that you are multiplying
This is so
the x by.
Oh, like the 2 in the other.
Mm-hmm.
Oh, okay.
Yes.
What did you write like the a? Like the absolute value of a?
Yes,
But what did you write after that?
as greater than 1.
Oh.
Okay. So if a is bigger than 1, right, because when the reciprocal is going to be a fraction, okay? And so we end up shrinking away from the x-axis. Okay. Versus what happens if I do the absolute value of 1/2 x? What did this one do? Did it stretches towards, okay? And so again, what is the reciprocal of 1/2? It's 2. So when I come over here and I see initially x is equal to 2, and then I multiply x by 2, that's going to take it to 4. Okay. I'm sorry, I'm looking at the wrong one. Yes.
Why are we multiplying by the reciprocal again?
Because on the when the a value is on the inside, it's happening to the x value. It's a reciprocal relationship.
Okay. So it's just like a rule.
Yes. Yes. I'm going back to the chart. Okay.
But when you say like the square root of a is greater than 1, it could also be greater than or also less than -1, right?
Yes, that's why we're saying the absolute value. Because if it's a negative value, it's just going to reflect it over. Yeah. So, okay. So this one here, if the absolute value of a is less than 1, we get a horizontal stretch. Yes. Okay. So we're gonna look at the y's also, and it'll start to come together.
Wouldn't it be flipped? Wouldn't it be the first one to be stretched and the second one to be stretched?
Okay. Well, you have to think about the relationship because it's happening to the x, so it's horizontal, so it has to do with the x-axis. So we're looking relative to the x-axis. This one here is the original, and when we multiplied by 2, what happens? It's moving away from the x-axis. So that's what makes that a shrink.
Think of it this way, Josie. So like you're here, and then when you have a number greater than 0, the like little angle in between shrinks like that, and there's less space between the lines. But then when it's less than 0, it goes like this, and there's more space between the lines. So it's like shrinking and like stretching.
But when on vertical, it's the opposite.
On the vertical, oh, the vertical stretch and shrink. Yeah, so it's different. Well, the effect is the same, but we're going to refer to them differently. Okay, so this time A is on the outside, so this is relative to the y-axis. The y values. Okay, and again, you get a stretch or shrink. And this one is a direct relationship. Okay, and so again, affects the y values, so we multiply y by A. So I'm going to pull the graph up again. I'm going to go ahead and take these two out. Actually, yes, I'm going to move that 2 to the outside here. Okay. So again, now we're talking about the y values. And again, it's a direct relationship. So for this one here, where x is equal to 2, right, we're going to take that 2 and, sorry, not the x, we're talking about the y now. Y is equal to 2. We multiply 2 by 2, and that takes us to 4. Here, y is equal to 4, multiplied by 2 takes it to 8. Okay. So again, direct relationship when we're talking about vertical. So again, now we want to talk about the relationship with the y-axis. So when we look at this one, is it stretching towards the y, or is it shrinking away from it? It's stretching towards. Okay. So remember, when we did this with the horizontal one, we said we were shrinking. It was a horizontal shrink. But now we're talking about its relationship to the y, and so now we're going to say it's a vertical stretch. All right, so what we have here is it's a vertical stretch. Absolute value of A is greater than 1. Now we get a vertical stretch. Yes. And this will all get posted too. Okay. All right. Let's come back to the graph. And now I'm going to take this and turn it into, actually, I'll make a new one. Okay. So let's look at this one. Alrighty. So again, we have a y value that started at 2. So this is y equals 2. And then we're multiplying y by 1/2. That takes y to 1. All right, same over here. Y started at 4, multiplied by 1/2, it takes it to 2. And so again, we're going to talk about the relationship with the y-axis relative to the parent function? Have we now stretched towards the y-axis, or have we shrunk away from it? This is a shrink. Okay, so we'll say the absolute value being less than 1 is a vertical shrink. Okay, so I know those of you that were here last year, you did these. Is it sort of coming back?
I think
Yes.
it is a vertical stretch of shrinks, but not the horizontal.
But not horizontal? Yeah, that would make sense. Okay. All right. On to the next one. So we said, what happened when you had the negative on the inside? What did we say happens? Well, the absolute value one stayed the same, and that's because it's a mirror. It's reflecting over the y, so it just ends up making a mirror image. So this is reflection over y. Okay, so what's happening is x values are multiplied by -1.
Is that the effect?
That's the effect, yes. All right. So as we saw, if I'm going to take that one out, let me adjust this one. Negative. Okay. So again, it's just a mirror image. So it's the x values that get multiplied by -1. So remember, the red graph was the original one, which is right underneath. We had x is equal to +2. That one is the one that got multiplied by the -1. It moved it to the -2. Right? And so with this one, because of the symmetry, they look exactly the same. Okay, one more. Let's see. Okay, and we said when the negative is on the outside, we reflect it over. Bless you. Reflection over x. Okay, so it's a reflection over x. So what values are being multiplied by -1? The y values. So y values are multiplied by -1. Okay, so again, if I pull up my graph here and I move that out and put the negative in there. So again, this point here is at y equals +2. We multiply that by -1. It shifts it to here. This here is y equals +4 times -1 becomes -4. So that's how we get the reflection over the y. Okay, what do we think so far? Okay? All right, so we're going to practice some now, and this is the paper that I passed out to you. This is the parent function that we are going to transfer, and actually it's not really a parent. What kind of function would we call this? Linear. One more term. How many pieces do you see? Yes, this is a linear piecewise function. Okay, so linear piecewise function. I gave you guys 4 copies because we're going to transform it 4 different times. Okay, so this is the parent function here. So our first transformation is telling us to do g of x minus 1. And that minus 1 is occurring where? On the inside or the outside?
Inside.
It's on the inside, so that means it affects which values?
X is right in one of them.
X values. Oh,
A little.
yes.
These all look the same.
Yes, they are. But we're going to transform each one of them in a different way. Okay. So when the minus 1 is on the inside of the parentheses, what is the effect?
Like 1.
Okay, this is a horizontal shift. Yes. Yes. So horizontal shift to the left or right. I think somebody said it already, right by 1. Okay. Do our y values change?
No.
The y values don't change, so y is going to stay the same. I'm just going to repeat them. We have 3, 0, 1, 1, negative 2. And to the x values, I'm going to add 1. So this is going to become x plus 1. All right, so negative 5 plus 1 moves that to negative 4. Negative 3 plus 1 moves that to negative 2. 0 plus 1, 1. 2 plus 1,
3,
and 4 plus 1.
5.
Okay, and these are going to be our new coordinates. Okay, so that's one way we can make the table and then replot the points and connect. Or also, because this one is just a straightforward shift to the right, I can just look at my coordinates here, the endpoints, and say, okay, well, that's over by 1. This is over by 1. This is over by 1, and by 1, and then reconnect. And hopefully your lines will come out straighter than mine are on here. I think you guys have already figured out I cannot draw a straight line on this screen. Actually, I can't draw a straight line on paper either. So. Okay.
Notes would be on, it's on like that, or like the completed notes. Like,
Yes, and then this is also being videoed right now. So then this will get posted today. Okay. Our next transformation that we're going to do is g of 2x. And that 2 is being multiplied to the x. So what did we say? When we're multiplying to x, what kind of relationship do we have?
reciprocal.
It's going to be reciprocal, okay? And so we're going to multiply which values? X values. So this is, I'm going to say reciprocal.
Then why isn't it just multiplied by 2?
Because it's happening on the x, and the x's are, I always just think the x's are complicated, right? Everything is opposite. When we're doing horizontal shifts, it's the opposite direction.
So that's why.
Yes, okay. When you're affecting the x's, you have to multiply by a reciprocal. Everything's just sort of opposite. Okay, so we are going to multiply our x values by what?
Negative or 1/2.
1/2, yes, just the reciprocal. Okay, so again, our y's aren't going to change. So I'm going to go ahead and repeat my y's again. 3, 0, 1, 1, negative 2. And again, my x values, I'm going to multiply by 1/2. Okay, so negative 5 by 1/2 is negative 2.5, or negative 5 over 2. Negative 3 by 1/2 is negative 1.5. 0 by half is still 0. So that point actually doesn't even move. 2 by 1/2 is 1, and 4 by 1/2 is 2, and these are our new coordinates. So again, you can make the table and plot those points, or if you're feeling pretty confident, we can just look at each of our x values knowing that y is not going to change, right? So for this one here, I know it has to decrease by 1/2, but the y doesn't change, so I just follow along the y and I come to, what do we say, 2.5. Okay. This point here, which is at -3, again, I'm not changing the y, I'm just going to move it from -3 to -1.5. 0 doesn't change. And then we've got this point here, it's at +2, and 1/2 of that is 1, so that's going to move it here. And we have this point here, it's at x equals 4, by 1/2 takes it to x equals 2. And again, we'll connect those. So what do we think of that one? Good? All right. Let's look at the next one. Okay, so we have -2 times g of x plus 2. So how many changes are occurring on this transformation?
2.
Okay. So here's the thing. Technically, it's not 2, but it's technically 3. However, because of that, we've got the multiplication by the 2 and by -1. We can combine those together. But I'm going to go ahead and mark. We have a multiplication by 2 and -1. And so again, we're going to go ahead and treat these together as a -2. And then that +2 is occurring on the outside, so that tells us to do what?
Go up.
To go up by 2.
Wait, where does the -1 come in?
Because we have a negative here.
Oh.
Right there. Okay, so we're going to sort of split this up. My table's going to look a little bit different on this one. So, are our x's changing?
Yes.
Yeah.
The x's?
Aren't they going up by 2? Oh, that would be
That's
the
the
y.
y.
Okay, so there's no change to the x values right now. So I'm not going to rewrite that column because I don't have enough columns in this table here. Okay, so the first thing I want to take care of is you have to sort of follow order of operations when you're doing these. Okay, and order of operations tells us parentheses first. Do we have anything going on inside our parentheses?
No.
No. And then what's next?
Exponents.
And do we have any exponents?
No.
No. Next thing is multiplication or division. Okay, so we have to take care of that multiplication first, and the multiplication is the -2. Right? So I'm going to take my -2 and multiply it by my y values.
I'm a little confused what the g is doing there.
The g is the original function. G of x is the original function.
Oh.
So that's that linear piecewise function.
Oh.
And then we're applying the transformation to it.
Okay, so g of x is...
What's that? Hold on.
So you're using g of x, but there's already a y in the problem, so I'm confused why there's 2 y's.
Because
Is x also y?
yes, but it's before it's been transformed. The y is after the transformation.
So it's 2 different values.
Yeah. So the g of x is the original function, and then we're renaming it as y because we're transforming it. Okay. What was your question?
Oh, what is the -2 doing to the function?
Okay, so that's, remember, it's occurring on the outside of it, and so it multiplies the y values. Again, when it's affecting y, it's a direct relationship.
Oh, wait, so the G doesn't do anything?
No, the g is the original function.
Oh.
Yeah. Okay, so we're going to take all of our y values that are in the original g of x, and we're going to multiply all those y values by -2. All right, so 3 by -2 is -6. 0 by -2 is still 0. 1 by -2 is -2. Again, -2. And then we have -2 by -2 is +4. Okay. So we took care of 2 of those things at one time just because it's easy to multiply -1 by the other value. So the next thing we have to do is shift up by 2. And again, does that affect x or y?
Y.
That affects y. So now what I'm going to do is I'm going to take my new y. So that's that new column we just made, and I'm going to add 2 to all the values. Okay, so our new y is -6 plus 2 is -4. 0 plus 2 is -2 plus 2 is 0. And we get that twice. And then 4 plus 2 is 6. So our new coordinates that we have, again, x didn't change, so x is still -5. But after the transformations, y is now -4. The next one, x is -3, y is now +2. The next one, x is 0, and y is now also 0. And we get 2, 0, and we get 4, 6. Okay. I heard somebody say we now have 2 columns for y, and that's because we did two separate things to y. And so we want to remember to use the last one because that's our final move. Okay, so plotting these now, I have -5, -4, -3, +2, 0, 0, 2, 0, and 4, 6. And the longer the line has to be, the worse it's going to look. Okay. Alrighty. So how do we feel about that one? Good. Okay, we've got one more that we're going to do to our parent function g of x. All right. Do that one right. Okay. So how many transformations are occurring on this one, Allison? You see 3. Okay, what are they?
Negative. You need to make the y's negative. Multiply by -1.
Okay.
And then
Plus
add 1.
2 for x, and then
Huh.
and then plus 1 for y.
All right. Which one do we need to do first?
X's.
The
Add
x's.
2 to the x.
Add 2 to x. So remember, you have to follow the order of operations. We have inside the parentheses that -2. So first thing is we are going to plus 2 to x's. And then the next thing is we're going to, what value gets multiplied?
The Y.
The y.
-4.
We're going to get -1 times y. And the last one is
Y. New y plus 1.
new y plus 1. Okay.
Oh, because inside of the parentheses.
Okay.
So do we need to make another column?
Yeah, you'll need more columns. I don't have enough columns in mine, but I'm just going to write to the side.
So there should be 3 inches.
Yes, we're going to do 3 things. Okay, so we said first thing we are going to add 2 to x. So x plus 2. All right, so that means -5 is going to go to -3. -3 goes to -1.
Wait, it's
I know.
-3?
-3 plus 2.
Oh.
Yeah. 0 goes to 2, 2 goes to, and 4 goes to 6. Okay. Are we done with the x's?
No. Yes.
Yeah, we are. We're actually done with the x's. Okay, so the next piece we have to take care of is this -1 times y. All right, so that just means we're going to flip all the signs on all of our y values. So that becomes -3, stays 0, we get -1, -1, and now +2. All right. And then the last one is we're going to take our new y and add 1. So we have -3 plus 1, -2, 0 plus 1 is 1, -1 plus 1, 0, we get that twice, and 2 plus 1 is 3. And I'm going to go ahead and rewrite the new coordinates, the final one. So our final x was -3, final y -2. We have -1, 1. I need to make a line here so I don't mix up my columns. Okay, we have 2, 0. We have 4, 0. And we have 6, 3. All right, so let me plot those. -3, -2, -1, +1, 2, 0, 4, 0, and 6, 3. And we'll connect those. Okay, how was that one? Good? Okay, I think it's time for a stretch break. We did a lot. Nobody's moving. Okay, so this next part here is, all we're going to do is describe the transformation and then give the domain and range for each of these. Okay. So in our first one, we have g of x is equal to, it's the absolute value of x minus 5, and then we have -4 on the outside. So let's describe in order what happens first.
Oh, you go
Horizontal
right 5.
shift.
Right 5.
Right 5. So horizontal shift 5 to the right. And then what do we do?
Down 4.
Down 4.
Vertically.
It's a vertical shift. Okay. Alrighty. And if I'm going to be honest, I don't actually write out horizontal and vertical. I actually just do this. Right 5, down 4. Isn't that so much faster? I'm okay with that. As long as you remember the terminology, I'm fine with that. Okay. When we talk about the domain of an absolute value function, are there any restrictions on it?
Well, it can only go in one direction.
Okay.
Right? Because it's either going up forever, down forever, right forever, left forever.
Okay. And so that's going to affect, does that affect domain or range?
Range.
Range, okay. So how about the domain? Is there any restrictions?
Couldn't it also only go in one direction forever?
Well, if it's on its side, it's not an absolute value anymore. Okay. So, yes, it's all real numbers. Okay. And as an interval, that would be -infinity to +infinity. Or yes, all real numbers. Okay. And the range, as you were saying, it's either going completely up or it's turning downward. Okay, so if we take this parent function who has a vertex at 0, 0, and first we shifted it to the right 5, that's this direction for you, and then down by 4.
Oh, -4, comma infinity.
Beautiful. -4 to infinity.
Is it close?
Yes, it is included.
How can you tell if it's included or not?
Because the vertex is originally on 0, 0, and it's just shifting 5 and then down.
It's like a
So
color
it's
in
still there. Okay. All right. Let's talk about b. I have 3 times the absolute value of x and then -1 on the outside. So which do we address first?
the multiplication.
Multiplication of 3. It's on the outside, so what is that doing? It's 3 times y, so that means it's
Stretch by 3.
okay, vertical stretch
By a factor of 3.
by a factor of 3.
We do need to do vertical stretch.
Can we
Yes.
write vert stretch?
I'm fine with vert stretch. Okay. So that was the first one, and then what?
Inflation down by 1.
And then down by 1.
Is that like a vertical transition?
Stretch, meaning when you say vertical stretch, it's going to go towards the y-axis.
So for the -1.
The -1, that's just a shift.
Oh, like a. So why should we convert?
Yeah, it's a vertical shift.
Okay.
So down 1 or vertical shift. Vertical shift down. Okay. Is the domain affected when we do these? No. So domain remains negative infinity to positive infinity. All right. Let's talk about range. We took this parent function that had a vertex at 0, 0. We stretched it towards the y-axis, which narrowed it, and then we moved it down. So what is the new range?
-1, comma infinity.
Yes. 1 to infinity. See, y'all are already pros at this. Okay. Next one. G of x equal to the absolute value of 2 times x. So the effect of this one, is this on x or on y?
It's on X.
It's on the x. So we have to refer to it as the horizontal. And remember, we said if it has to do with x's, complicated, it's reciprocal. Okay, so this one is going to be a horizontal. Yes.
Is it a horizontal stretch?
Yeah.
This is a horizontal shrink
Because it's on the inside.
by 1/2.
Oh, because of multiplying.
Yes. And it's moving away from the x-axis. And Jane, I heard you explaining that perfectly.
How it's just basically the opposite.
It's opposite, but you always have to refer to it in the reference as from the frame of reference, right? So it's just like if you and I, if I stood in the middle between Caroline and you, and I go this way, I'm stretching towards you, shrinking from her.
Right.
But if I go this way, I'm stretching to her, shrinking from you.
It's just a weird way to describe it.
Yes. Yeah. Okay. So, is the domain affected?
No.
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 Domain is not affected. We can still plug in any x value we want to. Let's talk about the range. We took a parent function right here that has a vertex at 0, 0, and we shrank it, so meaning we moved it away from the x. Did we? The origin hasn't moved.
So it's
0,
comma infinity.
0 to infinity, yes.
Wait, what was the range for B?
For B,
-1.
Yeah. all right. Let's look at. Ready to look at D?
Yes.
Okay. So we've got negative on the outside, and then the absolute value of x plus 2 is on the inside. So what do we do first?
Reflection in the x-axis.
Hold on. What happens first?
Oh, in the side axis.
Inside first. So
To the
left 2,
and then you do reflection.
and then we're going to reflect over what?
X-axis.
Reflect over x.
How do we know which axis was reflected?
If it's inside the absolute value bracket.
So if it's inside, it's on that's on the Y.
Yes.
Okay, and then outside reflection.
Mm-hmm. Okay. Is the domain affected?
No.
No. Domain stays the same.
What is the domain reflected?
It would be like if we were doing like the square root of x, then that would affect the domain. Okay, so again, we started with this parent function that's doing this. The vertex is at 0, 0. We moved it to the left by 2 places, and then we reflected it over x.
So it's
Negative infinity and negative 0.
Negative.
0?
Negative comma 0.
Okay. Yeah. Did we shift up or down any? No. So it's still 0. It's just going downward. Which value do we put first?
Negative infinity.
Negative infinity goes first. Negative infinity goes
I said
to.
negative 2 and she said 0. So I said negative 0.
Okay.
You start from negative to
Y'all were pretty awesome at that. Okay. Changing gears a little bit here. Now we're going to write the transformed equation based upon the description given to us. Alrighty. So it's saying here, again, our parent function is going to be the absolute value of x still, and it wants us to write a new function called g that takes x, translates it 10 units upward, and then reflects in the x-axis. Okay. So what's the first thing we would do based upon what it's asking?
Plus 10.
The plus 10 on the inside or the outside?
Outside.
On the outside. So the first thing is we take the absolute value and then we add 10.
And then
Okay. But then it tells us to reflect over x.
So negative on the left of the absolute value.
Okay. And we have to put it on the outside of the whole thing. So that's the difference here. We have to put the negative on all of it.
Oh,
Hold on.
What?
Yeah, this is a weird one.
Because it's afterwards?
Because it's after. It's all about
But
the timing.
But didn't you say that last time? Oh, because it's on the outside. not the
Yeah.
inside.
But isn't it multiplication, so it comes first?
So let's
But
see.
But it's do the reflection second, so.
Okay.
I totally agree. Oh, and then you could just simplify it.
Mm-hmm. Okay. Oh, remember you were asking when is the domain affected? And I said square root. Here it is.
Yay.
Okay. I'll pull that up in Desmos. We can look at it. Okay. So this one, the parent function is the square root of x, and we're going to translate it 9 units down and reflect in the x. No, sorry, in the y. Reflect in the y.
What'd you first do square
So first first it's telling us to do what?
Go down 9.
Down 9. So that means, is the 9 on the inside or outside? It's on the outside, and it's going to be, is it plus 9 or minus 9? Minus 9. Okay. And then we want to reflect in the y-axis.
So that's going to be on the inside.
That's going to be on the inside, and it only affects, yes, square root of negative x minus 9.
was
Okay. So g of x, well, we'll look at that. Negative x minus 9. Okay. Okay, well, let's look at it in the graph. Let me clear that one and clear that one. Let me see if I can pull up the, oh, there it is. Keypad, okay. The square root of x. Okay. So there's the square root of x.
I remember looking at one of these graphs and saying,
Now, what is the domain?
all real numbers. No, wait,
No,
no, greater than 0.
Yeah.
Greater than or equal to 0. Okay, because again, you can't do a negative square root, right? Okay, well, what happens here when I do square root of negative x? Is that still a function?
Yeah.
It is. What happened to the domain?
If x is less than.
Is less than or equal to 0, right? Because we have a negative on the inside. So what are the only x values we can plug in there? They have to be negative. Yeah, or 0, because you'll get the double negative, which makes it positive. Okay, so that's that one. All right, so this last part here is we're going to write a transformed equation based upon a graph. So this first one, yes.
For this, for the domain, would this one just be like all of the negative numbers? Is that what the domain would be?
Actually, all the yes, because it's a downward shift. So the domain would just be all anything less than or equal to 0.
But not negative.
That won't affect the domain. It's going to affect the range, though, because it's going to shift everything down. Okay. How many of you have worked with x cubed? X cubed?
Possibly. It sounds.
Okay. Or the graph of x cubed, I should say.
AX squared.
No, it would be like ax cubed.
Oh, cube power.
Oh, wait, that's
Yeah.
3.
Yeah.
Yeah.
Okay. So what we have in this one here, it is a cubic, and I'm guessing you probably haven't worked too much with those. We are going to work more with them. I recognize it as a cubic, so I'm going to start this out as f of x is equal to. There is some sort of a stretch or shrink happening to it. I don't know what it is yet. So what I'm going to do is plug in an a in front of it. That's like the coefficient that's multiplying it. Yes.
Just like looking at A, I wouldn't even know that that's what how to stretch or shrink. What does the parent function look like? Because I don't know it.
The parent function it's x cubed. So let me just take this out here and do x. And where's
Either
my
A, B,
cubed?
and you can add it.
Okay, so that's the parent function.
Oh, okay.
So x cubed. So without anything happening to it.
Okay, so it's 2 cubed, and then that's 8. Okay.
Okay, so what's happening here is this cubic is going through the point 2, 2. And so I need to figure out what a is equal to. So what I'm going to do is I'm going to replace my y with the 2 in the graph that I know it goes through, equal to, again, I don't know a yet, and the corresponding x to that y equals 2 is x equals 2. Okay. So that's going to give me 2 is equal to 2 cubed is 8 times a. Can we solve for a?
Yeah.
Yes. What is a equal to?
A is equal to 1/4.
1/4 And now I'm just going to plug that back in. The equation of this graph is f of x is equal to 1 over 4 x cubed. All right. And our last example of the day. All right. What do we recognize the parent function as?
That is the absolute value of x.
It's an absolute value of x. Notice the vertex.
It is below 0.
It's below 0, which means
it's
what's
gonna be
happened.
-3.
There's a -3 in there. Okay. So I'm going to start with my f of x is equal to, and I'm going to do a times the absolute value of x, but we know it went down, so I'm going to put my -3 in there, showing that it went down.
Wait, how do you know it's minus? Oh, because it's in between -2 and
Yes.
4.
Why do we have the A on?
Because we know there's a stretch on it, so we have to figure out what that stretch is. All right. And so again, I know that it goes through the point -2, 3, so I'm going to plug that coordinate set in. So y is equal to 3 is equal to a times the absolute value of -2 minus 3. Add 3 to the other side, I get 6 is equal to, and the absolute value of -2 is +2. So I get 2a there, which means a is equal to 3. And so our function is f of x is equal to 3 times the absolute value of x minus 3. So what do we think of that one? Okay.
It's simple.
All right. Overall, how are we feeling about the transformations? Pretty good. So it's the vertical stretches and no, the horizontal ones are new to you guys.
Well, I don't understand how to graph them. Like, why are they graphed the same as vertical?
It's about it's about which value are you multiplying? Are you multiplying x and keeping y, or are you keeping x and multiplying y? And so that's why whether we put the 2 on the outside of that absolute value versus the inside, they came out the same because the x's in one case were being halved, and in the other case the y's were being doubled.
Okay.
So it gave the same effect.